All right, so all about quadratics. First thing to know about quadratics is that they come from the squaring function. So the relationship here, the way you turn the input into the output is that you square it. You can also do this as y equals x squared, but hopefully you've done enough of algebra to understand the function notation. So I'm going to use that. And if you really want to understand the relationship between the x and the y right here, I think you can make a table. And then when we really don't understand what a function is, we want to use numbers on both sides of the zero. So we're going to plug in -2 to +2. Let's start with the 0. If we make x equal 0, f of x, or y, is going to also equal 0. Because 0 squared, 1 squared is 1, 2 squared is 4, and then don't brain fart on the negatives here. -1 times -1 is +1. -2 times -2 is +4. So this is what a quadratic looks like, at least on a table. If we want to better understand this on a graph, we can sketch this out. 3, 4. So we're at 0, 0. Here, let me change my color here just so we can see this a little bit more clearly. We're at 0, 0. We're at 1 over 1 up. We're at 2 over 4 up. We're at 1 back and 1 up, and then 2 over and 4 up as well. You can see that this makes the quadratic symmetrical, meaning it's the same on both sides. And this right here is called the vertex, which is the most important part of the quadratic. If you have a negative quadratic, it's going to flip the other way. You can imagine all of these numbers become negative here. And so positive quadratics look like smiley faces. There's x squared. Negative quadratics are frowny faces. These guys are positive and they're happy. They're negative and they're sad. So that's what I mean by the word quadratic. The function is quadratic here. That's the name of maybe this. And then the shape that it makes is called a parabola. So you'll hear those two words, interchangeably sometimes. So there you go. Now, I'm going to show you something else which also counts as a quadratic. Something like this. So you look at the leading term, and if the degree is 2, the highest degree, then it's a quadratic. So you can still have what's called a linear term and a constant term. This is called a linear term because if you had just that, it would make a line. This is the constant term, and then this would be the quadratic or squared term. So different pieces of this quadratic. But hopefully you've done some polynomial operations now, so you can maybe learn that this comes from multiplying two binomials together. If you do x plus 2 times x plus 3, and you do what's called foiling or double distribution is how I prefer to call it. You do x times x for x squared, x times 3 for 3x, 2 times x for 2x, and then 2 times 3 for 6. Notice you have these two middle terms, which are usually like terms in these double distributions. Always for quadratics, you're going to have these two repeated linear terms, or two linear terms that you need to combine. So that's why it goes from 4 terms to 3. And then, of course, if you're doing this the other way, you need to make a t-chart that lists all the factors of 6, because this number came from multiplying the 2 times 3. So if you're trying to reverse engineer this, you need to know what multiplies to make 6. And your options here are 1 and 6 and 2 and 3. And then we see that this 5 comes from adding those two numbers, and that comes from combining the two like terms, which is why we get 5. So we're looking for numbers that multiply to make 6 and add to make 5. And I think you can see that it's going to be the 2 and 3 there. So this is how maybe two binomials become a quadratic like this. So Not only is x squared a quadratic, but so is this. If you were to graph this, it would have a shape that looks like that. So the reason that we want to change it from this form to this form is because we can do something interesting with this form. We can use what's called the zero property, meaning if we wanted this whole equation to equal 0, and then remember what the 0 represents. It's in the y's position or the f of x position. So if this were on a graph, if we're saying y equals 0, we're looking for points that are on the x-axis here. So this is called factored form here because we break it up. This is standard form. This is how we usually see it. So maybe this is the standard, and then we can convert standard form into factored form by factoring it. But the reason why factored form is nice is because it's easy to convert the factors into solutions. And the way you do that is you set them equal to 0. And then you solve. So in this case, you subtract 2 from both sides, so you get x equals -2. And on this case, you subtract 3 from both sides, and you get x equals -3. So that means the solutions where it hits the x-axis are 2 and 3. And so if you go to graph this quadratic, it's going to look something like this. And you can see that's a somewhat accurate representation of what it's going to look like. It's not perfect, because the only points I have are the solutions, but the vertex is going to be under the x-axis here, and it's going to point up, and again, you can kind of use the factored form to see what it's going to look like. Now, there's one more thing I want to say about this, and that is the vertex. And I'm going to come up with a new example here just to make this a little bit easier to think about. But let's say we have this as our factored form. X minus 2 and x minus 6. We're going to set both of those equal to 0. You'll see we'll get to the solutions of x equals 2 and x equals 6 very quick. And we can graph these. 1, 2, 3, 6, 2 right here. I'm going to use a different color for this example. 2 right here, and then 6 right there. So we have a quadratic here, and if we were to multiply this whole thing out, we would get x squared. Like, we can convert this back into standard form by just multiplying all this out, and I'll kind of skip some steps here. Minus 8x plus 12. We see that this x squared here is positive, so we know it's going to look like this. So now the question is how do we nail this thing down a little bit better? And you can maybe see here, because again, the quadratic is supposed to be symmetric. So that means these 2 points, if we were to find the middle of these 2 points, that would tell us the line that the vertex has to be on. Now, we don't know how far up and down it needs to be. We know it needs to be under the x-axis, so that's why it's a smiley face here. We don't know exactly where it's going to be. So the first thing we can do is we say, all right, well, what is this point that's halfway in between those? Yeah, you can kind of visualize it and see it's 4 here. Or the way that you find averages is you add them together, and then you divide by the number. So, 2 plus 6 here is 8, and then 8 divided by 2 is 4. Which is why the x part of the vertex, the x-coordinate of the vertex, is going to equal 4. Then, if we think about this, if we know the x part of a point, how do we find the y part? We plug it into the function, and that will get us the y part. So I'm going to, let's see here, erase this so we get a little room. I'm going to plug this x equals 4 into this equation right here, 4 minus 2, and then 4 minus 6. 4 minus 2 is 2, 4 minus 6 is -2, and I'm multiplying those, so I get -4. So if my x is 4, see how this is my x and this is my x, it gets me a y that's -4, and now I have both parts of my vertex for -4. And if I come and I put that on the graph right here, you'll see that nails my vertex down pretty well, and I'm able to draw in my quadratic a little more accurately. So I'm going to stop the video here. And really what this is it's a review of what a quadratic is, how you can change a quadratic from standard form into factored form, and then how you use that to help you graph the quadratic and kind of figure out what it should look like. So solutions, you get those from the factors. You do the opposite of the factors because you're setting those both equal to 0. You know, x minus 2 equals 0, x minus 6 equals 0. You move them over. The x-coordinate of the vertex is halfway through those 2 points. And then once you find the x part, you can find the y part by plugging it in. So hope this video was helpful. I'll see you soon.